Okay, so thank you everyone for coming to this talk. I am Nishant Srivastava. I'm an Android engineer. I'm working from Berlin. And today I'll be talking about and libraries stop starting up. So this particular topic is something that's very dear to my heart because I kind of keep on working with Android libraries a lot, either in the open source or at work or kind of like helping people out. And then doing a lot of SDK development has brought it to front a lot of things that are happening, right? So the first thing that I want to maybe that comes to everyone's mind is why are we even talking about Android library starting up? Well, the thing is that there are many ways of initializing an Android library. Some of them are good, some are bad, some are okayish, but mostly this whole landscape is very chaotic. And the important question here is that what can be done to unify this fragmentation? But because we are talking about initialization of an Android library, the first thing that we need to understand is how do we even kind of initialize Android libraries? Some of the stuff that I will talk about is you probably would know, but it is going to transition into something that will eventually provide more context. Okay, so let's first figure out what are the different ways of how Android libraries can be initialized. The very basic one that most everyone would be knowing about is that you create a class and then you use the constructor to kind of pass in a value and then initialize the library. So in this particular case, I'm going to take an example here. What it is doing is that it has a start string as a variable or as a value property, and then this has a string called authorization :bearer and then space. And then what I'm trying to do is I'm trying to construct an authorization header that has authorization : bearer space and then the token value for it. So then there's a function here that allows me to make that change. I have change token function to which I pass the token string, and then internally it is basically doing a concatenation. Simple stuff. And then the get auth header is basically kind of a getter to get this concatenated value or processed value. Now, the important point to note here is that I'm using the init block to immediately change the token as soon as I create my lib instance, right? So if I had to use this particular my lib class, I would, in my main activity, say private val mylib, and then use the constructor to initialize the library. And as soon as I do that, the init block is kind of triggered. And my auth header is kind of set up already. By the time I come to textview.text, mylib.get auth header, it is a complete authorization : bearer and then the token value 123. But because I can also make a change by calling change token by myself, the actual value would be authorization : bearer space 456. It's pretty simple stuff. The another version of doing something like this is that you actually use an init function. So I'm not using the constructor anymore. What I'm going to use is something which is like a standard normal function, and I'm calling it init. It's not the init block, it's an init function that I am defining on my own. And it does the same kind of stuff that we saw earlier. It takes the start string and then it concatenates the token to it, and then there's a getter for it. Now, notice the section that I'm highlighting, and that is the fun init function call, which internally calls change token. Now, this is because it's a simple function. When I am about to use this, this actually gets onto the user of this library code to call this init function. So mylib.init needs to be explicitly called after it has been initialized. So I created mylib, and then mylib as a constructor, I'm calling it, I'm initializing it, I'm creating an instance. But to initialize it with the proper value, I need to call init. If I forget to call init, and let's say there was no change token either, mylib.get auth header will just return authorization : bearer and then no value. There will be no token in it. So that init function that I'm calling is something that is burdened onto the developer who is using the library to call it. If they forget, there's some mess up that's happening. The third version that we can talk about is that when you are trying to initialize a library, you could also do it using a lifecycle observer. To do that, very simple stuff. You set up a Gradle dependency. You kind of set up an API in your libraries modules, build.gradle file. You set up lifecycle runtime KTX, lifecycle common Java 8. And what both of these actually provide you is that it gives you access to default lifecycle observer, and later on also to use your lifecycle observer, add lifecycle observer, remove lifecycle observer. So what we are doing is that we are kind of implementing the default lifecycle observer. And because of this, I'm able to override fun on start and override fun on stop. Now, this is also the same kind of code. The logic is not changing. There's a start string, there's an auth header. The only thing that is happening now is that the actual initialization, as in the change token function, is being called in the onStart. And then the reset is something that will basically get rid of this string. So when you call reset, it says auth header is equal to start string, brings it back to whatever the initial value was supposed to be. And it will basically just get rid of the extra token that you have. In order to use this, you basically do the same thing. You say mylib 123, as in you pass it in the constructor, but the actual initialization does not happen at this time. It is a bit deferred, and it will be based on the life cycle. Now, to start listening on the life cycle, what you actually need to do is that you need to be adding the observer in your onCreate. So you say add lifecycle observer, in this case, lifecycle.addObserver mylib, and then lifecycle.remove observer mylib. So what is happening here is that because you have created your mylib class as a default lifecycle observer, it's going to start observing the lifecycle once you have added it as an observer. And then it will not initialize in the onCreate, but it will only trigger the change token when it has gone through the onStart. And then when it goes to onStop, it will reset it. So that's like another way of initializing a library using a lifecycle state, observing the lifecycle state. The other version to, if you wanted to see an example of this, actually, you could see this. This is a pretty long back, but in August 2018, lifecycle awareness was added to Picasso. This is basically a screenshot of that thing. There's a link for that pull request that you can check out later on. But basically, libraries have been doing this for a very long time. It's not like it's not coming up right now in my presentation. It's been there for some time, and they have been trying to iterate over time as they found better patterns of initializing. The another version of actually initializing a class, library class, is that you just use a singleton class, right? So what I'm going to do is I'm going to change the code a little bit, but the end result would be same. What I'm doing here is that I created an object mylib class, which is kind of a singleton in Kotlin. And now I have a start string. I have the auth header. But the init function, what it's doing is it's taking in as a context, and it's using that context to get a string value from the string.xml file. So you can see r.string starting underscore string. And then the change token is kind of the similar function, but it's using the Kotlin way of writing things. And then get auth header is the same. The r string starting underscore string is something that is in your string.xml file, kind of the similar stuff, authorization, bearer. The reason I've actually split out the initialization with a context is because I want to showcase something in the next few slides. But if you were to try to initialize this library, the way that you would do is that you will call mylib.init, and then you will call mylib.changeToken, and then mylib.getAuthor. But notice the mylib is basically your singleton class, so it's not an instance. But you still have to call the init function. Okay. Now, as I said, I specifically want to show you about the application context, is because this application context does not kind of make sense, and it feels like a bit of redundant work to do. So if there are other libraries that are also doing this, for example, like Coil, which I think most of people know now, is an image loading library for Android backed by Kotlin coroutines. This library was not doing singleton before, but eventually turned over to doing something similar. The developer specifically now also wrote a blog post about it, detailing how they made the decision of switching over to using a singleton to initialize the libraries. You can look through the code base. There's a github.com link, which you can check out later on. But what it eventually led to is that in trying to do something like this, you still have to burden the developer to include that initialize application context. So people didn't want to do that, and they turned to different other options and hacks that they could think of. And this is when something like using a content provider trick comes into play. Okay, so mostly people did not know about this until Firebase one day released a blog post about this. How does Firebase initialize on Android? They released this in December 21st, 2016, and there's a link for this that you can check out and read later on. But basically, the summary of their blog post was that the reason you can actually use content provider to initialize a library is because a content provider is created and initialized on the main thread before all other components, even before the application class. Okay, and a content provider participates in the manifest merging at the build time. So what does these two things actually mean? Like if you had to do this, well, the result of using a content provider, which we'll talk about how to do it, eventually means that you as an app developer who is integrating a library does not have to call init with an application context anymore. And your library is like automatically initialized. And if you are doing something with the context, you could continue doing that within your library once you have the context. So let's try doing something like that. We are gonna create our own content provider. This one will be called mylib init provider, and it's gonna extend from content provider. What this does is that it gives you access to an onCreate function. And inside the onCreate function, you actually have access to the context. So if we were using the Singleton class setup of initializing the library that I just talked about, I would, instead of saying mylib.init application context in onCreate of the activity, I could just do the same thing within my content provider. So what this means is, so in the onCreate, I could do this. And also I need to do one more thing, that once you have created a content provider to the class, you also need to add into the manifest. So what you need to do is that you also need to add a provider. In this case, you are providing, like you are adding a tag inside your manifest file. So it looks like this. Notice there's a section here that is the application ID, which is a manifest placeholder. What it does is it takes care of your application package and it puts it inside your authorities string. So it will say something like com dot your example app dot my library, just to make it unique. The content provider has to be unique. So in that sense, it has to do this. So it's like also a pattern. I'm mentioning this because you would not put your own package name just for the sake of it, because it could conflict in the future. So when you try to run something that has the content provider set up and you try to integrate this into an application, as we already mentioned, content provider works with the manifest merger state, right? So if you look at your Android manifest and click on the merged manifest part, you can actually see the provider making that change. And you can see the authority string has also changed. It now says github.issues example using content provider to init library dot mylib. And this, everything before mylib is actually my app's package name. So that way, this is unique. And also you can see where this manifest is coming from, which I've highlighted on the side. So in the integration side, when you are, as an app developer, are going to integrate this, what you do is that inside your main activity, you can get rid of that line, mylib.init application context. You don't need it anymore. What you just need to do is that how you want to change the token. You don't worry about the context part anymore, and you can just go ahead and change the token. The rest of the code kind of looks the same. You kind of go and get the author header once you have made the change for the token. So who is using this? Well, in AndroidX domain, process lifecycle owner is still using this. Okay. Okay, I think I can start from this point. I hope this was where it didn't work. Anyways, so yeah, so where is this being used? So in AndroidX domain, process lifecycle owner is where this is actually being used. It makes sense for process lifecycle owner to actually use this because they want to track your application process as soon as it is up. So the content provider trick used by them is actually good. We know content provider starts up even before the application class, so definitely they should be using it. Work managers also using this. They also definitely need this because they want to schedule your jobs as soon as they can. Firebase Common is also using this. When I say common, is probably meaning that there are other libraries from Firebase also who would inherit the common library. And this means that they will also get this Firebase initialization happening, even if you don't want to. And also Firebase is also the one that has kind of like made this public. They were kind of like the ones who showed the world that this is how to do it. So more people started doing it. So it makes sense that Firebase would have it. And obviously Facebook would also do it because they want to track you everywhere. They have it in their core package. That means if you are doing something related to Facebook marketing, Facebook something else, interstitials or something, the transcript dependency it will pull in is Facebook core. And that also means that Facebook library internally is getting initialized even if you don't want to. So using content provider is not the best, but it has this thing that people want to use it. For some reason, there are many libraries that are using this. The problems it actually comes with is that libraries can auto-init, yes, but even if you don't want them to initialize, let's say in the case of Facebook, they would initialize themselves. They will ping home. They will make a request or something that they have set up in their initialization code to do that. And also, when you have this content provider trick set up, the content provider is going to get started as soon as the process starts. So your startup slows down. You see sluggish app startup because you just integrated a library which has dropped in its own content provider, right? And as soon as the content provider is loaded up, the libraries are starting up on their own. Obviously, when you are doing this, there's a memory overhead involved. Every time you try to start the application, it will kind of allocate a memory for initializing its instances and its objects, and that's why you don't want this to be there for you. Okay, and obviously there is no other order of init possible. So for example, if you had 5 content provider SDKs installed in your application, they would all try to compete with themselves to initialize as much as they can. And this means that maybe your app would crash, it could start. At some point, I don't know if you remember, but Facebook also had this problem that they started crashing a lot of applications, which was mostly coming from their initialization code doing a lot of memory work. So that started crashing apps that were out in the open, and people were using this SDK everywhere. So you don't want the content provider trick to work almost all the time. The things that
maybe you can turn on your camera again.
Let me try. I think I need to create.
Yeah.
Okay.
No. Yeah.
Okay.
Cool.
Okay. Great. Let's wait for this load up. Okay. Yes. So the other problem that we have is that content providers runs on the main thread. So your UI thread in general is going to get affected. If you have some animation to show up, it's going to maybe, if the initialization is happening on the main thread, then your UI would have sluggish animation or something. As I already mentioned, it increases your startup time of the application. You have sluggish UX. And obviously, we are abusing the functionality of content providers. Content providers were never meant to just inject context into some sort of a library, but rather they are there to do interprocess, or sometimes getting content from different other applications or something, right? So you are abusing the functionality of content provider. And that has kind of that's been out there, people know about it, but then still they are using content provider. So how do we tame these bad actors, like these libraries that are triggering on their own and you don't want them to trigger at all? They are making your application sluggish, they are increasing the startup time, and basically you just don't want that to happen, even though you do need to keep the library in because you require some functionality for them. So the best way to do this and to get rid of this content provider in general is that you use merge marker rule, which is part of the Android manifest XML. And you just put the tools namespace, and then you say tools : node in quotes remove. How does it look like? So if imagine you have a provider, let's say it's my own libraries provider, and I created something called github.nishrules example mylibrary.mylib_init provider. This is my personal provider. What I will do is that I will add the tools : node remove marker on it. And what this means is that when the merging happens, then this whole provider would not be there. This whole tag of provider would be gone. Because we are talking about the merger a lot, we need to also understand there's a merge priority setup. The libraries manifest file is the one that is actually merged into the main Android manifest.xml. And libraries manifest file has the lowest priority. So what you do want to do is that you want to make sure that any changes that you do something that's after the library's manifest file. So you don't want to do some sort of a hack to work on the library's manifest file by making some changes like using some scripting or something, but rather if you make that node change inside your main Android manifest.xml file and you added the tools :node remove, then it will remove the provider by the time it reaches the main manifest file. And then obviously it goes into your build variants manifest.xml, and then you get the final Android manifest.xml. That also means that if you want to remove the content provider in a very specific build, you could do that in your build variants Android manifest.xml file itself. So all of this is good, but what's next? What's the different thing that we can improve to fix things? And this is where AndroidX Startup comes in. It's called by different names. People now call it App Startup. Sometimes people call it Jetpack Startup. Basically, it's part of Android Jetpack. It is a library that is used to implement a straightforward and performant way of initializing component at App Startup. And basically, you can get the sources of this right now if you wanted to check it out on github.com. AndroidX repository, and inside that you have the startup folder that you can check it out. A point to note though is that it became stable quite recently. It was in October 28, 2020 when this library actually became stable. What this library allows you to do is that it's allowing you to initialize libraries without having to define a content provider on their own. Now, on their own is a very important point to note, is that this library is injecting at least or at minimum one content provider. So what it's saying is that if you start using AndroidX Startup, you don't have to create your own content providers and have like say 15 content provider in your manifest file with 15 libraries starting on their own. What it's saying is defer all of that to this library, where this library would start itself to start other libraries later on. And it will take care of starting them in a more optimized manner. So it allows you to do lazy initialization, which means that you can initialize other libraries at a later point in time. And you can also define an order of when the initialization happens, which was not possible if everyone was doing their own content provider and it was not working out. So how do you actually set this up? Well, very simple. In your library module, or if you're trying to do it within your app, you can also set up, you just implement the AndroidX Startup runtime. And then what you do is that you actually create a lib initializer. Now, this code might look similar to how you create a content provider, but it's basically a simple class. And you create your version, you kind of extend or you implement the initializer abstract class, and then you override the fun create and fun dependencies on this. Now you're also passing mylib in this one, just because you need to tell what kind of a class it needs to initialize. So in the fun create part, where you are actually getting the context reference, is where you will initialize your library. You will say mylib.init, and then you pass the context. This code looks like a bit tricky, but like this is like a set pattern that you use. The other section of this, the other function is called func dependencies. Basically, what it is used for is that if, say, for example, you have your library A and then you have your library B, and if you have to initialize your library A, you definitely need library B to already be initialized. So this is where the dependencies function would come in, and what it will allow you to do is that it will first initialize library B and then initialize library A. In our case, if you don't have any, say, dependencies, then you just say empty list. There is nothing to initialize before initializing the standard library. So you don't define anything in there. But if, say, for example, you did want some other library to initialize, what you would do is that you will just pass in the class reference to it. You will say list of my awesome lib initializer. It's another initializer, which also looks similar to this one. And then you pass :class.java. So what this means is that your awesome library would be initialized first, and then mylib would get initialized. Now, because, as I said, AndroidX Startup injects at least one provider, you need to add the provider for AndroidX. And this is where this comes in. Basically, this is like something that you will copy paste. It has the same thing, but it's only one provider that you will add. The thing that you actually change is the metadata part, which the AndroidX library reads, and it kind of knows, it discovers those initializer to start initializing a library. So in this case, let's say you set up AndroidX Startup Initialization Provider, which is like the same stuff, authorities exported, node, merge. This is same. It will always be the same. But if you had to add another library, you will add metadata with the name of the initializer with the full package name. And then the value is always going to be AndroidX Startup. If, say, you also understand that because we're talking about content providers, we said it always initializes on the main thread, right? But if you did want to initialize AndroidX on a different process, there is a possibility of doing that, and that you just need to define the process name on this one, on the provider tag. You can, like, this is something that mostly you should not do it because it comes with its own caveats, but I'm just putting it out there that there's a possibility of doing this. However, there's a better solution of actually doing something in a more deferred, in a different process version. But you can also do this. But what if you actually want to disable the whole initialization that we were seeing even from, say, AndroidX, right? So what we want to do is that we already talked about this in the taming the bad actor section. But basically what we are saying is that some library uses AndroidX Startup, and it already has the provider setup, and you actually don't want that library to start on its own. So you do the same trick again, but the pattern has changed a little bit. Instead of actually putting the remove node tools colon node remove part on the provider, you're going to put that into metadata. Why is that the case? Well, the case exists because AndroidX actually understands which library to start by looking at the metadata. So you don't want to remove the provider if you just want to remove one library from the system. If you had 3 of these and you just wanted to remove one, you will put the remove node on the metadata, not on the provider. However, if you actually want to get rid of the whole thing, like you don't want AndroidX Startup to start at all, is when you will actually put it on the provider. What you're trying to say is that I don't want even AndroidX to start with this content provider. But if you don't use the content provider, is the library still usable? Well, in a way it is, although the whole trick of like initialization by AndroidX Startup was being covered by the provider, but it does allow you to do lazy initialization. And this is where the app initializer class comes in. So what it says is that, first of all, the provider must be disabled. You are agreeing that there is no provider that will trigger the initialization. And now, if you do want to initialize, you decide when to initialize a certain library. So because we just disabled AndroidX by removing the node from the manifest, now you say app initializer get instance, pass in the context, and then initialize the component by using the initializer class. The one that is for my library, maybe it could have another one for my awesome library, but this also allows me to do it in a deferred manner, to do it later at a time. I don't need to do it inside the application class. I could totally do this within, say, when someone clicks a button and then initialize my library. You get the control from this, but it's like it's both sides. You definitely also lose the functionality of not burdening the developer of calling the initializer code. Right? It goes back to the same thing that if you could just have called mylibrary.init function call, and that would also do the same thing. So how good is it? Well, in general, we already talked about all of this stuff, but I'm just summarizing it, that it allows you to do the ordered manner of dependency initialization. There's also lazy initialization. Only one single content provider is being used instead of, like, say, multiple of them. You do have access to lint checks also, which will allow you to catch some bugs. The problem, though, is that it still uses the content provider trick. So we haven't got rid of it completely. It is still abusing the trick of using content provider. Also, there's no support for asynchronous initialization. The multi-process init is basically saying that if you do move it to a different process, then it's initialized on that process. But it's not going to be initialized or available across multiple processes. That's still not there. It is restricted to the main thread or to a one specific thread, but it cannot, like, jump between different processes, and people can get, like, multiple initialization on different processes. Still cannot do that. there's a bug tracker that you can go and check it out, but it doesn't have a lot of bugs, which is either good thing that there are not enough bugs, or maybe it's just that not a lot of people are using. So take it with a grain of salt. Mostly people are who are reporting bugs, they are not super bad bugs, I would say. They are usually something related to their own personal library, and then they are trying to do something unique which the library has never thought about. So are devs actually using this? Well, the short answer is yes. There are many applications that are using the libraries that are using this. Like, for example, What the Stack, Sentinel, Phone Emoji, there's Retro, there's also TikTok, which are all using this right now. And what's next is that the idea is that AndroidX libraries will be migrated to the Jetpack Startup, like Work Manager, Process Lifecycle Owner, Firebase app. All of these actually should get migrated to using the initializer setup using AndroidX Startup, but somehow they have not been doing that. Even the latest version that I've checked, the ones that are in beta or in RC, they haven't yet done it. So maybe it is on the track that it will be done maybe in some other version, but we don't know yet. Hopefully, more library developers would start using Jetpack Startup. The only thing that it's actually doing is reducing the chaos that exists right now inside apps. As library developer, it is probably on your side to make sure that your library or your SDK is not causing a lot of problems to the app developers. So even though it's not the best thing to do, it is still better than what's already existing out there. So every example that I actually talked about, you can find it on GitHub. There's a repository that I've already created. It's called Android Lib Init Examples. It has all the different versions that I was talking about, using normal class constructor to init library, class init function, LifecycleObserver, Singleton, ContentProvider, AndroidX Startup. All of that exists. And you can check that out when you get time, and maybe when I share my slides. One thing that I kind of could not talk about because maybe I'm running out of time, but in general, is that how do you actually measure the startup performance of your application if you integrate a library and if you remove a library? So the general trick is that you actually use ADB to kill the process, and then you start the process or your main activity, your application again, and then you check the time using ADB, how much time it took to start the application, right? So that whole process and how to do things by locking the clock and everything is something that people have been doing for a long time. But I am kind of linking a blog post written by Chet Hase, who actually wrote Testing App Startup Performance. He kind of goes through it in quite detail. So I would suggest that you go read that out. It's like a 10-minute read blog post that he's written. He's also written something related to AndroidX also. But basically, it's a very good read, and also something that you should check it out if you want to benchmark how your application is starting up and how much time it's taking when you add a library, when you remove a library, and when you start using AndroidX Startup. What's the difference? The idea is that if you start using AndroidX and you had, say, 5 libraries using ContentProvider trick, then your time kind of reduces considerably, probably by like a lot of milliseconds or something, if it goes by that. And that's all. Thank you. And if you have questions, I think I need to check them now. I'm gonna stop sharing to see if it works.
Thank you very much.
Thanks, Nishant. Great talk.
Okay, let me also go through the Q&A quickly. So any side effect of compiling for app bundles mainly required for instant app, multiple modules? So I think instant apps are kind of like not being used a lot, but if you are compiling for app bundles, the manifest file is still the same. You're not changing that. So the content provider is still getting delivered, and that means that even when you load the application, the libraries would get initialized. So that's not going to change or bring any difference. It's still going to be sluggish. It's going to cause some startup penalty for you. And there's one other question: is there a way to check which of the libraries and Gradle dependencies are using ContentProvider or AndroidX Startup? Yes. So I showed one of the slides which were talking about when you open up your apps manifest file and you click on the merged manifest, you can scroll and you can start looking for provider tags, and you can obviously see which all libraries have injected it. So on your right, you have sections which says where does that content provider comes from. So you can see if it is coming from, say, AndroidX Startup, and it has multiple initializers to it, like metadata is in there, then you can already figure out which libraries it is referencing to. But if it is not using AndroidX, and you can see, say, Facebook Core, and then it shows you a provider related to that, then you know it's coming from Facebook Core. Okay, I think that's all the questions.
I think you skipped one question.
Oh, the test question.
Yeah.
Which has
What's your
30
take on
words.
this?
I don't think so there's anything related to testing on this, but the best one is that you can do, as I mentioned, you can read the blog post I linked at the last. I will share the slides later on, which you can check out. And also that's the kind of testing that you will do. You will check the time before and after adding a library or using a Jetpack startup library.
All right.
Cool.
Thank you very much. Oh, another question just came in.
Yeah.
Oh, let me see. Is there support for custom initialization, something similar to Work Manager, Work Factory? Yes, exactly. So this is the one that I was mentioning earlier. So towards the end, I was talking about manual initialization or a lazy initialization, and that was related to calling the app initializer class. You get the context, but you need to disable the provider now. And you are the one who is responsible for initializing the particular class. So you say exactly that I want to initialize this particular library, and I want to maybe trigger this particular init function using the initializer. But again, if they don't have a pre-set up initializer, then you are on the mercy of the the library developer who gave you a certain way of initializing a library. The trick of custom initialization is only when you are using a content provider trick.